In this video, we're going to discuss molarity of solutions. So generally in chemistry, we need moles. Our balanced reactions use moles. Relating one chemical to a second chemical, we need to do through moles. And so we need moles of things. Solutions, when measured with things like weight percent or volume percent, might give us mass or volume, but that has to be further converted into moles. To do a reaction, you need moles, and so a concentration unit that involves moles is the most handy. And this is the idea of molarity. Molarity is just moles over liters. And so let's say you have 0.75 moles of sodium chloride, and you put it in 0.500 liters. I have so much chemical, I have a volume. My molarity is just those values. 0.75 moles of my chemical over 0.500 liters of solution. It's a ratio. Molarity is just a ratio that lets us convert between liters and moles of a chemical. Now, generally, we don't like to do it over a half. We tend to standardize these for 1 liter. Well, if you have one container and it has two things in it, so you had 2 dots in 1 liter, and then you had a second container and it also has 2 dots, and so it's 2 dots in 1 liter. Well, if you combine them, it becomes 4 dots in 2 liters. They just scale up. Our 2 over 1s, if we have twice as much stuff, we're 4 over 2s. Our ratios multiply just the same as they do for weight and volume percents. If I have twice the volume, I will have twice the moles. If I had twice that, if I go up to 2 liters, well, I'm going to have twice the top. It'll be 3 moles. These ratios must always be equal to each other. Increase your volume, you have to increase your moles to keep the ratio the same. So there are many we could write. We like to standardize them to 1 liter. The way to do that is whatever value you have, just divide them. 3 divided by 2 is 1.5. In fact, we rarely write them as the ratios. Generally, we will say that you have a 1.5 molar NaCl solution. Big capital M means moles per liter. It is 1.5 moles over 1 liter. Let's try to put this to use. What if I have 0.25 milliliters of a 1.21 molar sodium chloride solution? And I want to do is find moles of NaCl. The idea is if I had a big container, 1 liter, and it had a bunch of dots in it, and I'm going to take out a very tiny amount. 0.25 milliliters is incredibly tiny. I'd take a little cup, I'd put it in, it'd catch some of the chemical, I'd pull it out, but I only have a small amount in there. So how much have I removed? How much sodium chloride is in that small volume? I know the whole container had 1.21 moles if it was 1 liter. How many are in my small container? Well, I need to get out of milliliters. Remember, molarity is in liters. I need to convert some units. So 0.25 milliliters, and there is 1,000 milliliters in every 1 liter. This is going to give me my liters, 0.00025 liters. That's a very small volume, but it's a quarter of a milliliter. It should be small. So I have my volume, 0.00025 liters, and I know that in every 1 liter of my solution, there's supposed to be 1.21 moles. So we can take our actual volume and multiply it by the ratio that the molarity tells us. 1.21 molar is 1.21 moles over 1 liter. My liters on top and bottom will cancel, and this will be equal to 0.000303 mole. 2 sig figs, so basically 3.0 times 10 to the minus 4 moles. So there's very few moles in this very small amount of the container we took out, which makes sense. Most of the container was left behind, so most of the moles was left behind. Another way we can solve this if we want is to use an equality. Again, some volume and some moles must equal, if it's from the same bucket, the same division. I know that there is a 1.21 moles in 1 liter. If I have a different volume, there is some moles that must be in that volume. Whatever x is must, when divided by 0.00025, equal the same thing as our right side does. Since I took it out of the same container, whatever moles came with this volume must have the same ratio as the moles that was in the large container. And so we can solve it mathematically. The way you do it is you multiply the liters on both sides. Effectively, that brings 0.0025 liters on its own to the right, leaves x all on its own. And so we get 1.21 times the smaller volume, which is exactly what we saw up above. But it's another way to arrange it. You can remember that your ratios must always be equal to each other when you actually do the division for the same solution. If you solve it this way, my mole will still equal 3.0 times 10 to the minus 4. What about making a solution? If 50 grams of NaCl is in 250 milliliters solution, let's find the molarity. Well, I've got a volume of solution, so I have part of it. Remember, my molarity is going to equal my mole over my liters. And so at the moment that is, 250 milliliters times 1,000, or divide by 1,000. 250 milliliters divide by 1,000 to get liters. I have 1/4 of a liter. I need to find those moles, though. 50 grams of sodium chloride, well, that's not in moles, so I have to convert it. 50.0 grams of NaCl. I need to get out of grams of NaCl and into mole of NaCl. Well, molar mass, grams to mole ratio. We can always get it from the molar mass. Look it up. It's going to be 1 sodium, 1 chloride. It's 58.44 grams in 1 mole. So 50 divided by 58.44, 0.8556 mole of NaCl. So I have my moles, 8556. I have my volume, 0.250 liters. If I divide them, I will find that it is 3.42 molar NaCl. It is 3.42 moles per liter sodium chloride. Now, I didn't actually make a liter of solution, and I don't actually have 3.4 moles. I have 1/4 of that volume and 1/4 of the moles. But we always report it as if you had scaled it up to make 1 liter, which is what dividing these two numbers will actually give us. It will tell us it is 3.42 mole over 1 liter. And so you can find your molarity for a solution if you know the moles of the chemical and your volume. If we had tried to put those 50 grams into a different volume, let's say 350 milliliters. Well, our moles are the same. It's still 50 grams, so 0.8556 mole. But my volume is now 0.350 liters. So this will give us a slightly different concentration. We've spread those moles over a larger volume. This will be 2.44 mole in 1 liter. So we just divide those two numbers and it tells us 2.44, which we tend to write as 2.44 molar NaCl. And I suppose we had 2 sig figs this time. By increasing the volume we have spread those moles out in, we have decreased the molarity. This is the additive molarity. It's our most common concentration unit for chemistry calculations. You will get a bottle that'll have a cap, and it will be something like 1.5 molar NaCl. It has already been mixed up so that you know the concentration. There's no need to weigh out a solid. It has been pre-weighed and pre-dissolved, and so you just need to know what volume of this to pour out to get the amount of the chemical you want.